Okay, last problem from this section that I'm going to go through. And this one is different in they gave you the equation already. Now, I know some of you in this class are going to be engineers. I know a lot of engineers normally have to take circuit analysis. And in circuit analysis, not even there, if you take physics, when you go through the electricity and magnetism section, you might even come across this equation, okay? It's the power equation for a circuit. It says if a resistor R ohms, okay, is connected across a battery of E volts with internal resistance R ohms, okay, little r, then the power in watts in the external resistor is, so the power is equal to, see, E squared R divided by big R plus little r, all of it being squared. Okay? So it says if E and little r are fixed, but big R varies, what is the maximum value of the power? So it says E is fixed. This implies it's constant. That's the same with little r. That's constant. So big R here is our variable, all right, and wants us to find the maximum value of the power. Now, where they get this equation from? I mean, you'd have to draw a little circuit and battery with a resistor attached to it and all that. And then you could work out the equation like that. But we're not going to do that here. You find that out in physics, find that out in circuit analysis. So, since we want to find the maximum power, we're going to do what we did all the other times. We found the derivative, we set it equal to 0, and we solved. Okay? Now here, we just got to remember that E and little r are constants. I'm just going to scoot this over a little bit. I just want more room. We're going to have to do a quotient rule. We've got big R on top. We've got little r on bottom. So P is equal to E squared big R divided by big R plus little r squared. So let's see. I'll do it over here. P prime is equal to, it's a quotient rule, all right? So all divided by big R plus little r to the fourth power, okay? Remember how the quotient rule works. It's a bunch of stuff on the top divided by the denominator squared. The denominator already has a square, so a square, and you're squaring it again, you're going to get a fourth power right here. All right, now let's work on the numerator, and this is the only place that we're going to care about. Because the only way this derivative is 0 is if the numerator is 0. So, derivative of the numerator times the denominator. On top, it's a linear function. This e squared here is just the number. Number times x, just like if you were to think about it with x's. So the derivative of x is just 1. The derivative of r is just 1. So we just get e squared. Derivative of r is 1 times e squared is e squared times the, not this denominator, times the denominator. Big R plus little r quantity squared minus the numerator, e squared big R, times the derivative of the denominator. So the denominator is going to be a chain rule. You got a power function on the outside, And then you got a linear function on the inside. The derivative of the inside is very easy here. So if you forgot that it was a chain rule, you would have been okay because it's just r. The derivative of r is 1. So the derivative of the inside is just 1. Like I said, you could have got away with forgetting the chain rule. But to do the power rule, bring the 2 out front, so times by 2. Drop 1 power. R plus little r to the first power. And we already talked about derivative of the inside is 1. Don't need anything there. Alright, so we're setting this thing equal to 0. Now, to set this equal to 0, we just need the numerator equal to 0. So let's go ahead and simplify the numerator a little bit. You notice, I'll do it in a different color. Look at right here, and look at right here. Each term has a common factor of big R plus little r. Big R plus little r. So what I'm going to do is, this is to the second power, this is the first power. I'm going to factor out a big R plus little r to the first power. And let's see what's left over. E squared times, well, I only took one of these big R plus little r's out, so there's one left over. Minus, there's a 2 here, so I'm going to put it out front. E squared big R. And then this big R plus little r, I factored out. Now, we do have the denominator here. Big R plus little r to the 4th power. I'm going to have to erase some stuff here, okay? I'll leave this bottom piece. I'm going to erase this middle portion right here, and the equation. We have the equation in the problem, so we can always look back at it. So we've got P prime is equal to, we've got big R plus little r to the 1st power. Now let's look at this right here. So distribute this E squared. You get E squared big R plus E squared little r. And now we've still got this, minus 2 E squared big R. So now, right here, we can put stuff together. We've got E squared big R minus 2E squared big R, which is a negative E squared big R. And then we got E squared little r. E squared little r. There's an E squared here you can factor out. And then it's R plus little r to the 4th power. Alright, so there's our derivative. Now we're going to set this thing equal to 0. And we're going to go ahead and solve. Now, again, we only care about the numerator. The denominator can't be 0. So E squared little r minus E squared big R equals 0. It's already factored, so we could set each piece equal to 0. This piece equal to 0. This piece equal to 0. R plus little r equals 0. Minus r. Big R is equal to negative r. Okay. This piece right here. Now E squared. I'm gonna factor out the E squared. E squared little r minus big R is equal to 0. I could divide both sides by E squared. And that's still 0. I get little r minus big R equals 0. Add big R on both sides. I get big R is equal to little r. Alright, so I've got these two pieces. big R is equal to plus or minus little r. I don't need anything else on this board except for that result and the equation. Because let's look at the question again. What is the maximum value of the power? I found the R, the big R, that gives me the maximum power, but now it wants me to find the maximum power. Okay, so this is a lot like the number 2, the volume of the box. Okay, what is the largest volume of the box? What is the largest power? So we get the power formula back up here again. Big E squared, big R divided by big R plus little r squared. Now, we had 2 solutions. We got plus and minus little r. However, can we have negative little r? Can we have a negative resistance? No, we cannot, okay? Resistances in resistors are a positive value. So we are going to throw out the negative. Not only that, let's see what happens if we were to take the negative version and plug it in. If I were to plug in negative r right there, negative r plus r is 0. I'd be dividing by 0, okay? So we don't need that. We don't need the negative version. So what we're going to do is plug in. And this would be the maximum power. E squared times little r divided by little r plus little r squared. Well, that's E squared little r divided by r plus r is 2r squared. E squared little r divided by 4r squared. And then lastly is equal to r there and r there will cancel. E squared over 4r. So now we have a max power of P is equal to E squared over 4 little r. Here's our final answer right there. Now, there's a problem. You should go ahead and try it. It's talking about a poster